back. In this video, we are going to discuss about types of function call. So what are the different ways to call a function? What are the different ways to pass arguments to a function? So this is what we are going to discuss, and then will discuss about another type of function that is called recursive function, and then function overloading. Okay, first let's see what are the different ways to call a function. There are two ways that a C function can be called from a program. They are call by value and call by reference. So call by value means, so far we have seen some programs like calling a function. So calling a function will be inside your main function, and if the function is going to accept some arguments, then we are passing the arguments, maybe integer argument or character argument or floating point, any different types of argument we are passing. So what type of values I'm passing, how do I pass the value? So that is called as calling a function. And calling by value means I'm going to pass a value inside the function call. So inside my main function, I'm having my function call, and inside the function call, I'm specifying the arguments. So if the argument is a value, then it is called by value. If the argument is a reference in the sense I'm passing an address, instead of passing a value, I'm passing an address. So the address will have the content. So these are the two different types of function calls. So let's see it in more detail. So call by value. In call by value method, the value of the variable is passed to the function as parameters. As I said, we are going to pass a value. Either it can be a direct value. For example, if it is addition of two numbers, if the function name is add, I can directly call the function as add 10, 20. Or otherwise, if the values are in a variable, I can call it like add a, b, if the variables are a, b, a and b. And similarly, I can use any variable names, or directly I can pass the value. That is called call by value. So already we discussed about actual parameters and formal parameters. So in the previous program, we discussed about actual parameters and formal parameters. So let's see in this program. Here I told you which one is actual, which one is formal argument. So here in the function, whatever variable name I have given in the argument list, that is called as formal arguments, and the variable I'm using it inside the main function is called as actual argument. So m is an actual argument, x is a formal argument in the previous program. And here a and b are actual argument, x and y are formal arguments. So the arguments which are mentioned in the function are called as formal arguments. The arguments which are mentioned in your function call or inside the main function are called as actual arguments. So call by value means the value of the actual parameter cannot be modified by the formal parameter. So what we are actually doing, we are copying the value of the actual parameter to formal parameter, and the formal parameters values are getting modified. So we are performing the operation on the formal parameter, not on the actual parameter. For example, if you see this program, a is equal to 10, b is equal to 20. So these are the two values. These are actual parameters, and the formal parameters are x and y. So here I'm just adding these two numbers, x plus y. So these two numbers will be summed up, and then we are printing the value. Or for example, if I'm performing any other operation like x plus plus or y plus plus, the values are going to be changed in this function, not here. The a and b value will not be changed, but the x and y value will be changed in this function, the local variables. Okay, so that is what it is mentioned. The value of the actual parameter cannot be modified by the formal parameter. So different memory is allocated for both actual and formal parameters, because the value of actual parameter is copied to formal parameter. So the values are going to be copied, and then it is going to be executed from a different memory location. So let's see another program. So this program is suitable for explaining call by value and call by reference. So in this program, the first line is a header file, and then we are declaring the function. We are declaring a function. It's a function prototype. It's also called as a function declaration. So the function is not returning anything, so it is void. Then the function name is swap. It is going to swap two numbers, so I have given the name as swap. Then it is having two variables, int a and b. So here a and b are formal arguments. Then here comes my main function. So int m is equal to 22, n is equal to 44. I'm just printing the function here. values before swap. M is equal to what and n is equal to what. So directly I'm going to print the value here. So what is m? M is 22 and n is 44. So after function call, what I supposed to do, I should swap the numbers. M should be 44 and n should be 22. So this is what I wanted to perform. So as of now, here you will get the output as m is equal to 22, n is equal to 44. Then I'm calling the function swap m comma n. So swap m comma n, when this function is getting called, so m and n are actual parameters. From these actual parameters, the values are copied to the formal parameters a and b. Then we are just performing the swapping operation. As we know, we are using a temporary variable here, int temp. Temp is equal to a is equal to b is equal to temp. Just swapping these two numbers using a temporary variable. After that, after swapping the values, after swapping, m is equal to 44 and n is equal to 22. The values will get changed. But here I have mentioned as a and b, but actually that modification is done in the formal arguments, not in the actual arguments. So this is what call by value. It's just like, don't be confused, it's just a regular program. How do you call a function, how do you pass a value? But whenever you are using call by value, the values are going to be copied to the formal arguments, and then it is going to be modified. You will get the output. So this is what call by value. So next one is call by reference. In the call by reference, the address of the variable is passed to the function as parameter. Instead of passing a value like m or n or 10, 20 or any other value, I'm going to pass the address of a variable. How do we pass an address of the variable? Address of the variable will be denoted by using ampersand in front of the variable. So ampersand represents address of a variable. So that address will be passed. So whenever I'm passing an address of the variable, so the value inside the address will be changed. So the values are not going to be copied. I mean, the variables, the value of the variable will not be copied to a new memory location, but the same memory location. From the same memory location, the data are going to be modified. So that is what we are going to see in this program. Here we are using pointer concept. In the next video, we'll discuss in more detail about pointer. Just a glimpse I will tell about this. Pointer is going to hold an address of another variable. That is called as a pointer. What is a pointer? Pointer is going to store the address of another variable. So in this program, I'm using two pointer as arguments. So pointer will be represented by using star in front of it. So asterisk a and asterisk b. So two variables I have declared, and that is called that is for arguments of the function swap. Then comes my main function, int m is equal to 22, n is equal to 44. And then here I'm printing the values before swap, m is equal to 22, n is equal to 44. That is what will be printed. Then I'm calling the function here swap ampersand m ampersand n. I already told you ampersand represents address of a variable. So address of m is passed and address of n is passed. So two addresses I'm passing, and then after that I'm going to print the value as m and n. So actually it is there is a mistake here. It's m and n. Okay, so that is what I'm trying to print. So void swap int star a star b. As I told you, pointer is going to hold the address of another variable. It cannot hold a normal value. So address of pointer a will hold the address of m. Pointer b will hold the address of n. Then we are having a temporary variable. So whenever you mention star in front of it, so the value inside the variable, value inside the memory is getting swapped here. So here I'm swapping the content, but actually the values are not copied to a new memory location, but it is changing from in the memory location, in a common memory location. So whatever modifications are done here, the same modification will be reflected in your actual argument also. So this function is not returning anything, it is not printing anything, but it is just doing the modification. But if I'm printing here values after swap, m is equal to, here it will be automatically swapped because I have swapped here, it is 44 and n is equal to 22. So this is what the output you will get. So this is what call by value and call by reference. Call by value means values are getting swapped here and it is local here, and then we have to print it over here itself. But call by reference means it is changing in the address, so it will be changed everywhere, so I can access it from my main function. So this is what call by value and call by reference. These are the two ways to pass arguments to a function. We can expect that we can expect this question as what are the different ways to pass arguments to a function, or what are the different ways to call a function. Similarly, it will be asked. The next topic is function overloading. Function overloading is very essential in our C programming. It is having a same function name for more than one functions. We know what is a function name, how do we declare a function, but how do we have more than one function with the same function name? So that is what called as function overloading. Function overloading means we'll have a same function name but different number of arguments or different types of arguments. So as I already told you, whenever we are having a function, the number of arguments we are specifying or the type of argument also we are specifying, and we have to specify the number of arguments. For example, if I have specified two integer arguments, then I must specify two integer arguments. I must pass two integer arguments whenever I call the function. But if I miss it, then it won't be called. Similarly, each and every function will be identified through the type of argument and the number of arguments. So I can have any number of functions with the same name but different number of arguments and different types of arguments. So that makes a function overloading. So the definition goes like this: in a C program, more than one function with same name but different number of arguments and different types of arguments is called as function overloading. So function overloading doesn't talk about return type of the functions. So return type could be anything. You don't need to worry about return type, but the function name should be same for all the functions, but the number of arguments and the type of arguments should be different. So overloaded functions can be called based on the type and number of arguments. So let's see this example. This program is having a number of functions, that is add function. So this add function, we are having four different types of add function. So the first function having two arguments, int a, int b. Second function is having three arguments, int a, int b, int c. Third function is having two arguments, float a, float b. Fourth function is having float a, float b, float c. So all four functions are different. So the first function is having two arguments. Third function is having two arguments, but the arguments are different, integer and here it is float. The first function int a, int b, and the second function int a, int b, int c. So these two functions are accepting integer arguments, but the number of arguments are different. So in that way, through the number of arguments and through the type of arguments, that functions are different from each other. So we have four different functions here. So let's see, how do we call the function? I'm just declaring three variables for integer, three variables for float, getting the values from the user, integer variables and then the floating point variables. Then I'm calling the functions here. So here I'm calling the first function. So void add, sorry, there is a mistake here. We should not use the void here. There is a mistake, sorry. So add x comma y, add m comma n. So add x comma y, I'm passing two arguments here. So what is the type of this x and y? X and y type is integer, so the integer function will be called. All right. The next function is add m comma n. M comma n is floating point variable, so the floating point function will be called. Okay, the function is not defined here. We can define just like the regular function. We can define it here, and then add x comma y comma z. X comma y comma z is integer, so this function will be called. Add m comma n comma p. So it is float, so this function will be called. So whenever you are calling the function name would be same, but the number of arguments you are passing and the number of type of arguments we are passing are different. So based on that specific function will be called. So this is what function overloading. There is one more topic left out. I'll just go through it. That is called recursive function, which is a very important topic. Recursive function. What is a recursive function? Recursive function is a function that calls itself is called as recursive function. We know how do we call a function. Function call, as I told you, it should be specified inside your main function. So only if the function is called, we'll get the output of a function. Okay, but here, how can a function be recursive? So that can be done by using recursive function. That means the function will call itself, so that makes the function recursive function. So there is a best example for recursive function is factorial program. So here I have a function called fact as my function, and the return type is integer. It is going to accept one argument, that is n. So n is the argument it is accepting, and then here comes my main function. So I have two variables here, int factorial comma number. So factorial is where I'm going to store the result. Number is a number where which I want to get from the user. So printf, enter the number to find the factorial. Scanf, I'm just getting the number, so ampersand number, so that means to the address of number I'm just storing the value. Factorial is equal to fact of number. So here I'm just calling the function because this function is going to return an integer. I have a integer variable here, okay, and then this is my function name, and then this is the argument I'm passing. Number is the argument I'm passing, and then I'm just printing the value here, the factorial of percentage d is percentage d. So number is what is the factorial which is calculated. So we know the normal factorial calculation, whenever a number is given, for example, if you want to calculate the factorial for n, then n factorial is n into n minus 1 factorial. That is what the output of factorial, n into n minus 1 factorial. For example, if it is 5 factorial, if I want to find a factorial for 5, it is 5 minus 4 factorial, then 4 minus 3 factorial, 3 minus 2 factorial, then 1 factorial. So in that way we are going to calculate the factorial. That means n is equal to the factorial of n is n into n minus 1. That is a factorial. So that thing can be solved by using this function, int fact, int n, that is the argument, and then if n is greater than 0. So only if the factorial value is greater than 0, I can find the factorial. If it is equal to 0, then it is the factorial of 0 is 1. So we have to return 1. That is why I'm having a condition. If the value of n is greater than 0, then I can perform the operation here. Return n star, that is multiplication operation, fact n minus 1. So what's happening here? N is a value which was entered by the user. So the actual arguments will be copied to the formal arguments. For example, if user has entered 5, so 5, the n value is 5. So 5 is greater than 0. The condition is true. And then comes to the return statement. Return statement, we know it is going to return the value to the main function. So return, when during the return it is performing some task, return n into fact of n minus 1. If you see this fact of n minus 1, these two are similar, fact number and fact of n minus 1. So here what I'm performing here, fact means the function, the same function. So it is going to call the function with the number. So what is the number? If the user has entered 5, so the value will be 5 into fact of 5 minus 1, that is 4. Actually I have user has entered 5, so first 5 is entered here, and then 5 is greater than 0, condition is true, return n 5 into fact of n minus 1. So what is the value? It is 4. So these two will be added. Then once again 4 will be coming here. So 4 into 3, 3 into 2, 2 into 1. When it becomes 1, when it becomes 0, we will get answer as 1. So each and every time the function will be calling itself again and again until it reaching the particular condition, and then you will get the answer. So this is what called as a recursive function. So whenever I mention 5 factorial, 5 into 5 minus 1 factorial, and again and again that function will call itself again and again. So this is a function call here, and this function call is calling the same function. So this function call will happen again and again, and finally you are getting the results. So that is called as a recursive function. The recursive function means a function that calls itself is called as a recursive function. In the next video, we'll discuss about pointers. How do we store a value to a pointer? How do we access a pointer with other example programs? Thank you.